Hello, I just finished doing LeetCode 118 and I thought I would share a good way of doing the problem with people on the internet. So this is Pascal's triangle. So it has ones in the corner and every row has one more element from the previous than the previous rows, okay? And you add those two to get that, right? And then you extend, you have one on there, you have a one over there, and these two elements meet up to give you 2 plus 1, 3. And again, these two elements meet up to give you 2 plus 1, 3. So as you can see, the Pascal's triangle is like before we go there, though, notice where the addition begins. You have no such addition when you are on row one. So this has to be a base case. You cannot do any magic. This is just given to you. So is row two. It has to be a base case. There is no magic for you to generate these two rows. Okay. Afterwards, you can start generating. Now notice, you use everything in a row 2 to generate only one node, right? Row 2 has no effect on those two corner nodes, okay? Similarly, let me remove these markings. You use all the elements in row 3 to generate two nodes, but that does not have any bearing on the corners. The corners are always 1. So from this diagram, we notice a few things. I'm just going to write them out. So row 1 and row 2 are base cases, meaning we have to return them, build them and return them, and there is no logic here, right? And then every other row other row, no, every row, sorry, every row starts and ends with 1. That's an invariant, okay? Always, any row you go to 100th row, it will also have 1 in the beginning and the end, okay? So that's the idea. And then uh, all nodes in the previous uh, row is used. So all of them are used to create whatever is in between, to create whatever is between those ones. Okay. You can also notice that here is one node, two nodes, three nodes, four nodes. As the row number increases, so does the node number, but in a linear fashion. So that's, but I did not find any use for that fact. I just wanted to point that out. So using this, we are gonna write our formula. And let me see, hold on. Found it. So here is the diagram of the problem. Again, they gave you a very nice animation that shows that all the elements of the previous rows are used to fill between whatever is between the ones, okay? So I'm going to actually show you my latest accepted submission. I took 1 millisecond and it's like 84, 85% of the other people. I am not shooting for this optimization. I'm happy with my results so far. This solution makes sense, and that's what's important to me. Okay, so here is the solution. I am returning a list of integers. So the nodes are integers, and each row in the tree or in here in the triangle are a list of integers, and the whole tree is a list of rows, okay? And I'm given a number of rows, okay? So at the beginning of the function, I declare a triangle, which is a list of lists, and this outer thing is a linked list. I don't need to index into it, so linked list is fine. And the first row, I am making the first row over here. Again, there is no logic here. This is a base case, okay? And I'm making it an array list because I'm making all my rows to be array lists. Array lists and linked lists both are lists, but array lists have the ability to access each element index into the array in constant time, unlike linked lists, which need O of n time, right? So I'm making a row. I'm making row one. I'm adding the value one to the row one, and I'm adding the row to the triangle. And then I'm doing an if statement. If this is I'm asked to get the first row of the triangle, I just return it. I prepared it, okay? And then after this point, there is more than one row. I prepare the second row, and the second row also consists of two ones. I make that, put it in the triangle, and then return it if that is the case. Beyond that, I am outside the base case. Now I can use logic. I start at I equals 3 because at this point I know it's more than 3. And I go all the way until an equal to the number of rows. So notice the equal here because I need to go up to that row. Okay. And now I am getting a reference from the triangle dot get last. Okay. So remember, this was a linked list. Linked list has a get last function. Uh, I made a comment that if I did not use get last, if I use get and then triangle.size, that's a variable stored, so that's O of 1. But this get operation will traverse to everything to get to the last element, which is kind of weird. We don't want to do that, so I'm going to use get last. I could have used an array list here, but I prefer linked list. Anyways, and then this row is I'm making a new array list. Remember, all rows are array lists because I need to access the elements in the array. Now, again, as we noted, we have to add 1 at the beginning of the row and at the end of the row. This is between the two ones. I'm going to use the previous row to make that. But at the beginning of the row, there is a 1. At the end of the row, there is a 1. And I'm going to use all the elements in the previous row to make up this, okay? Now, the way I do this is I make a for loop and notice that j goes up to previous row dot size -1. So I'm not going until the very last element because on every iteration of the loop, I am using up two elements. If I try to use this in the last place, I will fall out of the array. So I'll go until the next to last entry. And what am I doing? I am just adding numbers to my current row. I'm calling that this row. So this row dot add. What am I adding? Previous row dot get j. So the jth entry, right? And then I'm adding the j plus 1, so the next entry. So that this is if j is 0, I am getting the very first element and the second element, right? And then j becomes 1, I get the second element from the previous list and the first element from the previous list. And so on and so forth until I'll just show you until I get to the last element. So as you can see, these two are used here, these two are used here, these two are used here. So I'm using everything, okay? And then at the end, I add the 1. And then whatever row I created, I add it to my triangle and then return the triangle. That's the list of lists. And that was the accepted solution. So that's the end of this answer. Thank you for your time. If you have any questions, please leave them in the comment. Have a good day.